Hi, this video we're gonna look at more example into the equilibrium, but I think the challenge for those examples are more in free body diagram. So I'm using the Webworks and I want to just give you some guidance on how to start with this problem, and I think the rest of the logic is very clear, right? You just put your equations there and solve it. So I think the challenge again lies in the FBD. So let's take a look at the first one. So there is a sag here and a person is pulling at AB direction. There's another rope tied on the wrench. At the wrench is AC. So they want to ask maybe the weight of the sag and or one of the tension. So imagine if I know the TAB that's given. No, would I don't know if this problem given TAB or TAC, but let's say TAB is 10 Newton and we don't know TAC, so it's along this line of the rope, TAC, and again start with A, and so we see that give us a direction. Then we also at this point A, there's a weight that's unknown. So those are the free body diagram for this one. Okay. Now let's move on. Then you can solve those two unknowns. Let's move on to this problem. They said this boat is carrying two payloads, one each side. The tension in rope BC, TBC is given as 3.1, and rod AB, so there's TBC and the TAB, free rotate at A. Find the force in rod AB and the weight of the payload right here. So in that situation, we're going to draw everything at point B. Basically, all the forces acting on B. We have the weight of the payload. That's going to be P, you're solving. Then we also have the tension in the rope BC. That's given. So it's pulling up the load from B to C, TBC, that's 3.1 kips. By the way, kip, 1 kip, kilo means 1,000. That means 1,000 pound force. 1 kip means 1,000 pound force, okay? So this potentially equal to 3,100 pound force, okay? Then we also have this rod AB. What do you think? In order to make this B at equilibrium, likely AB is going to be pushing into the B, right? So in that situation, the force is going to be along the AB. If I extend it, it's going to be along the direction of the AB and it's pulling it up. Then that could be balanced. So that's TAB. By the way, if you decide if you didn't think about it, you said, I'm going to consider it's going this direction and it doesn't really matter. Remember, you're going to get an answer. If you assume this is going to be this yellow color, your answer is going to be negative value. And that negative value corresponding to this negative, yellow arrow, which means the true direction is going to be actually pointing upward. So it really doesn't matter. So you could go either way. Okay, so I'm going to erase that. Okay. So then you can solve your TAB and P. And for this problem, again, they didn't give you the angle, they give you the dimension. So go ahead, have very clear logic to get the dimensions down. Again, for Webworks, round your answer at the end. That will prevent the tolerance error. Okay, the next problem, they give us a cylinder. They said it's suspended by a rope set on inclined surface and the weight. So if I were thinking about the center, that's where I'm going to apply all the forces now. There's a weight that's going downward. For mine, it's 1880 Newton. Then there's a normal force, right? They're asking what's the normal force gonna be. The normal force is gonna be perpendicular to this inclined surface. So that's gonna be, if I were extending a dashed line, but this is gonna be our normal force. Then we also have the tension in this rope. So we're gonna call this tension going that direction with the angle psi here. So that's going to be our tension. That tension is not known, and that normal force is not known. And then we can solve this too. Okay, so the challenge I see here is when you decompose the normal force. So I'm going to just demonstrate that. So here, this is going to be inclined surface with angle theta. Then the normal force is going to be perpendicular to that, right? That's our normal force. If I were to decompose the normal force to x direction and y direction, because we have to, right, kind of, when we construct our equation, you're going to figure out how is this theta translated to this right here. So here I'm going to demonstrate. If this angle is theta, we know this angle is going to be theta. And if that angle is theta, we know this angle is theta. That's how that's done. Why? Because this theta plus this beta is equal to 90 degrees because it's perpendicular. Normal force is going to be perpendicular to the inclined surface. And also we know this is x component, y component, so that is 90 degrees as well. So if this is beta, we know this angle is for sure theta. Okay, that will help you decompose this force N. Okay, that's a little tip for this problem. Then the last problem, they said a farmer's tractor is stuck in muddy pasture. And so to free the tractor, the farmer ties a rope to a tree right here and then pulls sideways. This is a sideway in the middle of the rope. So this force is given as 451 Newton. And the angle theta is given. And it's midway, so which means this is like symmetric. And find xy component of the force applied to the front of the tractor and in a position. So basically they want you to find the force Tx and the Ty at the front of the tractor. So how do we solve that? If we were to looking at the FBD of this point to the midpoint of the rope, then let's draw all the FBD. We will have this force, 451 Newton, and then we also have this tension, those two tension. And since it's symmetric, you can actually prove it. This tension 1 and tension 2 should be equal, right? Because they share the same. When you're gonna decompose, you realize this angle and that angle, it's the same, so you're gonna get the same. Okay, Ty is equal to T2 because the x component of the T1 and x component of T2, they have to balance each other. And then, okay, so that x component of the force is gonna be equal to this Tx, and this y component of the force is going to be equal to Ty. And for this problem, a quick demonstration is the 2t, if this is Ty, the 2Ty is going to be equal to this force. Why? Because that's only y component of the force. Sum of what y equal to 0. Okay. And if you know the y now, then you can totally find a Tx, because this is Tx and this is your Ty, and they give us the angle. Let's see, the angle, this angle is theta, so this angle is theta. Then you know Ty is going to be equal to tangent theta times Tx. So you can find your Tx. All right, so that's for those problems, and hopefully it's helpful, and I'll see you next time. Bye.